it visible? Students, is
Yes,
it
ma'am.
visible? I've shared a
Yes,
screen.
ma'am.
Okay, thank you so much.
Yes, ma'am.
Because today is the first day of the week's lecture, so let me do a quick revision of what we have been studying so far. Okay, in the past, what 1 week, what we have studied. I'll just give me 5 minutes. I'll do a quick revision of the same. Uh, by now, I think 10, 11 of you have joined, so I think you must have been attending my lectures in the past week. So by now you have already known that we are studying operating system. Okay, so in the operating system, if you remember, then in the first lecture of the operating system, we studied what is operating system. We studied 2 or 3 definitions for operating system. After that, we studied the components of computer system, and in the components of operating system, computer system, we found that it follows a layered architecture. Okay, in the layered architecture, we found that at the bottommost layer we have the computer hardware, and the topmost layer we have the users. Okay, and in between, that is on top of computer hardware, we have operating system, and on top of operating system we have system and application programs. Okay, post that we studied various purposes of operating system, wherein we found that there are 3 purposes of operating system. One is to provide execution environment, second was to provide proper utilization of resources, and the third is to provide controlling programs. Okay, so after having studied that, we studied what are the various main functions. That is, if somebody wants to develop an operating system, what are the basic functions or operations that operating system must do? That means there is no choice on that. Those are the list of functions that operating system must do. Okay, so on that list we studied process management. Okay, that means it is responsible for creation, updation, suspending, resuming, deleting of processes. It also has to provide process synchronization. It has to establish communication between different processes. It also has to handle deadlock. Okay, we have studied this. After handling processes, the job of the operating system is to manage the main memory. Okay, so in the managing main memory, it has to keep track of which part of the memory is currently being used and by which process. It has to decide which process get loaded in the main memory, which process has to come out of the main memory when new request is submitted. It has to allocate or deallocate the memory space as that means if the memory space is already full, the memory should be freed, reallocated, and reallocation to new should be done. Okay, suppose that we studied file management, and then we studied system management. After that, we studied the fifth operation that the operating system has to perform is the management of the secondary storage. After that, protection of the system. It has to make sure of reliability. While discussing reliability, I told you that if any service is there and it's not reliable, we end up not using it. Okay, so the services that the operating system has to provide should be reliable, so that when we submit a task or a job to operating system, it must complete the task. Okay, after that we studied program execution, and input output operation is the sixth function of operating system. It also has to handle communication and error detection, resource allocation, and accounting. Okay, so these were the various operations that the operating system has to perform, and we have already discussed it. After that, we studied that what are the various views in operation, what are the various ways to look into an operating system. Okay, so when we talk about using or developing of a new operating system, there are 2 ways to look at it. One is the user view and another is the system view. So these were the topic that we discussed. First lecture, we only introduced ourselves, and I told you the syllabus. I told you the name of the book. Second lecture, we discussed all these basic topics. And in the third lecture, we studied the evolution of operating system. Okay, so in the evolution of the operating system, we found that there are 5 or 6 evolutions, and under each evolution, evaluated operating system, under each one there are sometimes different evolution in itself or different types in itself. For example, in the first discussed operating system, mainframe, that means the operating system that the user, that was accessible to the users, where we found there are different types there. Okay, the first was the batch system, then the multi-program system, and then the interactive system, and then time sharing system. These were under mainframe system. Then we discussed desktop system. Okay, after desktop system, the machine has evolved in handling multiple processes. Okay, that is multiprocessor system, wherein we have also used the term parallel system, wherein we have multiple systems executing in parallel to complete one single task. Okay, after that, in network, the operating system that is used is called as your distributed system. That was your next type. Under distributed system, we study client server based system and peer to peer system. Okay, and then after that, the next stage evaluated system was the clustered system, wherein I discussed that different systems with their own resources are put together, are put in one place so that they can complete one big task. Okay, they will have their own resources like own memory and processors. After that, we studied real-time systems, the systems that are used in aircraft, ATMs, etc. There we studied 2 types. One is the hard real-time and another is the soft real-time. I gave you example for both of them. Okay, so hard real-time, I discussed flight-based operating system. Soft real-time system, I discussed about ATM machines. Okay, operating systems used in ATM machines. The last operating system that we discussed is the handheld systems. Okay, that is easy to carry systems, which are usually meant to serve 1 or 2 purposes. Okay, so this is all we had studied so far. So do you have any questions till here? If yes, please raise your questions. If no, please give me a go signal so that I can start with today's topic. Any queries from what we have discussed so far?
No, ma'am.
Can I start with the new topic, students?
Yes, ma'am.
I couldn't hear you, Chandni. Chandni or Rojesh, it was, I don't know. I couldn't hear you.
Yes, ma'am.
Okay, thank you, Rojesh. So from today, we'll start with the, while I was doing the quick revision, I told you that one of the operation that the operating system has to perform is the process management. Okay, and that is what we are going to discuss from today. Okay, so that is your, so today we are going to discuss process. So this will be the topic for the day. Okay, so always remember, with process, one more term is associated, that is your program. Okay, so there is a fine line difference between program and process, which is even usually asked in your vivas. Okay, so what is a program? A program is anything that you have written, okay, but that is currently not in execution. You have written it, you have saved it. Okay, so it's there in a file, it is saved as a file, but when you execute that same file, when that program, when that file is in execution, it is called as a process. For example, before I started with this lecture, the board that I'm using to teach you guys is the Paint 3D. I think you can see my screen, right? So you can see here the application that I'm using is Paint 3D. Before I opened this Paint 3D, it was a program that was installed in my computer. Okay, but now I have opened it and I'm using it. Okay, so now currently this is a process. So when a program is put into execution, that is when we call a program as a process. The moment I'll close this window, this process will come out of the CPU, it will come out of the main memory, and it will be stored somewhere in your system. Then it is called as your program. Okay, so now process is extremely important in your process, and main memory is extremely important to understand in your operating system, because when we have multiple processes, that means when we have a lots of programs executing simultaneously at t equals to 1 at a given point of time, when we have multiple programs executing simultaneously, then we will have to handle these processes, because we know that in main memory we can put more than one process. अच्छे से सुनो इस statement को. The statement that I'm going to say right now, listen to it very carefully and remember it. In main memory we can have more than one process at a time, but in processor we can have in one processor we can have only one process at a time. If we have four processors, then it's a different thing. You can have four programs submitted to each of the processor, but remember one memory can have multiple processors, but each processor can have only one process at a given point of time. So now for multi-programming concept, what we have to do is, it is about context switching, switching from one process to another in the CPU. Okay, so it has to be managed. So something has to be remembered, something has to be allocated, something has to be deallocated continuously to perform multi-programming concept. Okay, so that is done if we have understood process very clearly. So let me begin with process and listen to today's lecture. आपका ये जो lecture है इसको अच्छे से सुनो ताकि आपको process के concepts बहुत clear हो जाए. And tomorrow's lecture is connected to today's lecture, so you need to listen carefully on today's about today's lecture. Okay. So I already told a process is a program in execution, and when we have a process submitted, it will need certain resources. Okay, एक process को certain resource की ज़रूरत होता है to get converted into a process from the program. Okay, for example, it will need your CPU time. Okay, a process needs your CPU time. A process needs your CPU time. A process, as I already mentioned, needs your memory. Unless a program is in the memory, we cannot call it as process. Okay, जब तक आपके computer में है, it's a program. The moment it is uploaded into your main memory and it gets the CPU time, that is when it is called as a process. And it also needs files. Okay, sometimes needs files, if like for example if you have opened Word file. Okay, so it's a file, and it's many types of process also needs input output devices. It needs to display something sometimes. Okay, so now these are the various resources that a process may need. Okay, more than that, it may need printers sometimes, scanners sometimes. So there are various resources a process may need. Okay, so now what does a process consist of? एक process में क्या क्या होता है? Okay, so a process may consist of a program code. A process may consist of a program code. Okay, for example, for this Paint 3D, a program is written. Okay, so now I'm using this process concept for program code. It is also known as the text section having the source code. That means when I open this Paint 3D, there will be a program that is running at the background, and if you open this program, it will have some text, it will have some content in it. Okay, and the next that a process may have is, okay, a process may have is this one is important, current activity. That means what am I currently doing with this process? Okay, so that is the current activity. Now to remember, because now if I submit another process into the processor, okay, this process, currently the paint 3D will come out of the processor, another process is being admitted. So before it is taken out of the processor and it is put back to the main memory, the current activity of the process has to be remembered. For example, I'm using this process right now. That means it is there in your in my CPU. Okay. So the moment I'll move out of this paint, now if I'll come to the browser like this, now that paint has been swapped out of the processor, and now this Google Chrome has been submitted to the processor for execution. So before that paint is taken out, it must, the operating system must store what was the last value of the paint, so that when I go back to the paint, whatever was written earlier gets saved. Okay, so the job of the current activity, it remembers all of that by assigning one value. Okay, so it is represented by the value of the program counter and contents of the processor's register. इसमें registers भी involved होते हैं, because we know that ultimately it is the register. Inside register, what do we have? Collections of flip flops. And what is there in the flip flop? It is a latch system. What does it store? It stores a value. How many values does it store? Each flip flop stores one value. Okay, we know that, we have already studied all that. So now to remember it, it has to call the operating system will have to call a register to remember the value. Okay, so the third thing, the third basic thing that a process consists of is the data section. Okay, so a data section is nothing but it is the current global variables. For example, if I move to another process considering this paint 3D, it should remember that I have some variables called as text wala section chosen. I have written all this. So for all these, some global variables are chosen wherein the current state can be saved. Okay, so these are the two things about process. First, what all does a process needs? Okay, and what all does a process consist of? So these are the two topics. Okay, so now I'm moving to the next topic of the day, that is the process state. Now when I talk about process states, remember students, process states are extremely important. Okay, there are various questions that are asked in um, multiple competitive exams from the process states. So now if I'll explain to you, even if I'll give you the notes, you'll mug it up, you'll write it in the exam. If I give the question, explain various process states. Okay, but when we talk about competitive exams, then they do not ask direct question. Okay, so what is the trick to answer those questions is, now I'm going to draw one diagram to explain you the process. The trick to answer every question is, remember this, do not mug up. Ratoge to bhul jaoge. If you remember it, then you can always correlate that question, whatever question is there, you read it very carefully, you put that question in this diagram and you try to answer it. Okay, so that way it will be very easier for you to answer any question related to process states. So tomorrow I'll teach you one more topic, that is the scheduling, long-term scheduling, short-term scheduling, mid-term scheduling, even that scheduling. This process states and scheduling are two different topics, but they are related. So today I'm going to draw this diagram and explain to you. Tomorrow while I'm teaching you that topic, I'll call your names. मैं एक एक जन को नाम से बुलाऊंगी and then I'll ask questions. Okay, अब मैं mid term पढ़ा रही हूँ. So now tell me process states के in which state does this scheduler belongs. ऐसे करके I will ask you the question by correlation, by relating. Okay. So now allow me to draw the diagrams. And this diagram is very important. Okay, so now I'm going to write here. How do I write here? I cannot write like this. With these shapes. So I have here new. I have here terminate. I have here ready. I have here running. I have here waiting. Okay, so now I need text. Okay, so these are the various steps. Okay, so now from new we can go to ready. We have arrows. Acha, okay. We don't have arrows or what? From ready we can go to running. From we go to terminate. From here we can go to from waiting we can go to the side. Okay, let me do the remaining with okay. This one and this one. Okay. So now is it. So this is your process state diagram. Okay, so this is your process state diagram. So in a process, we have 5 states. Okay, so we have it's a color yeah. Okay, so black. So in a process, we have 5 states. The first state is the new. Next is ready, running, waiting, and terminated. These are the 5 states that any process will have. Okay, so when you process, for example, if a sorry, for example, let me say that I choose one more application from my list of applications installed. Okay, that means a new process is created, or in layman term, if I have to say, the process is being brought from your secondary storage and it is uploaded into the main memory. Okay, जब आप main memory में submit करते हो, that is when you create a new process. It is called the state is in the new, we admit a new process. Okay, so now when that new process is ready, every time a process is created does not mean it is ready, because after a new process is created, various values are there that has to be assigned to the process, and we call it as PCB, process control block, that I will tell you later. Okay, so before a process gets the processor for execution, a process control block has to be assigned to that process. So now all that happens in the ready state here. Okay, so ready, we in the ready we assign these processes with the things that it needs for execution, or saving its last state or current state, or the what it need, what all resources does it need. It has to be made ready in the ready state. It has to tell in this state that I need keyboard, I need let's say a mouse, I need all of this for this many amount of time, something like that. So it is called as your ready state. New is where a process is being created, and your ready is the process is getting to assign to a processor. Always remember, when a process is in ready state, it is not yet assigned the processor. However, it is there in the main memory. ये सिर्फ main memory है मैं. Let's say this is my main memory. Okay, so I have processor P0 in my computer. Let us say it is there. This is your calculator. This is your main memory, and this is your suppose CPU. Now you have brought this processor P0 from a secondary storage to your main memory. Okay, so now it is there in the P0 is there in the main memory. That means we call it as ready state. Okay, so from the ready state, when it gets the CPU, when it gets inside the CPU process P0, we call this process as the running process. And right now it is in execution. Okay, so it may happen so that while it is in execution, to that process, two things may happen. Okay, yeah.
Excuse me, ma'am. Ma'am, your screen is not visible.
मैम आपका वर्ड ब्रेक हो रहा है.
Ma'am, your screen is not visible.
Okay, so is it visible now?
Yes, ma'am.
Is it visible now? Okay.
Yes, ma'am.
Okay. The other person was saying that my voice is breaking. Is my voice clear now?
नो मैम.
Okay, अभी ठीक है? अभी ठीक है अभी right now? Okay, so let me repeat then. Okay, so from where should I repeat? Should I repeat the name of the states, or should I repeat this portion?
Ma'am, repeat.
Then from beginning.
From new.
Okay, okay,
Ma'am,
students.
from beginning.
Okay, so we have a program installed in our computer. Okay, so that is not called as a, let us say, calculator. I have not opened the calculator so far. So because of that reason, that calculator as of now will be called as a program. But after I open that calculator, that program becomes a process because that calculator is currently in execution. For example, this Paint 3D screen right now. So it is currently in execution and it is also in the CPU. Okay, then it is called as a process right now. So the moment the class gets over, I will close this window. Then again, it is not in execution. Then again, it becomes from a process, it becomes a program. Okay. So when we talk about program, it has no state because it is not in execution. It will have no state. But when we convert that program into a program in execution, that means when it becomes a process, it will have states. Okay, it will have states because from the secondary storage, first it is brought. See here, it is there in the secondary storage. This Paint 3D was in the secondary storage. To take your class, I opened it. So when I opened it, it went to the main memory. Okay, I opened it and I waited for you guys. So it was not in ये सिर्फ main memory में upload होके बैठा था. I was not using it. I was there in the Google Chrome and I was waiting for you guys. So it was there in the main memory. Now I'm taking my class. I'm doing certain stuffs in this Paint 3D. That means now from the main memory, it has been brought to the CPU. Processor में it has been brought. Now it has been converted from one state to another state. Again from other state to the third state. So because when we talk about process, it is completely moving from one place to another. And when it is there in the processor, it is doing certain stuff. So now if I'll go back to my browser, these values must be saved so that when I come back to this page again, all these things must be there. Okay. So that means to a process, certain states are assigned. Sometimes we pause it, we move to the next because we need another resource. Okay. For example, right now I'm showing you and the process, this particular Paint 3D is only using one resource right now. That is the display screen. Now, if I choose again writing something, that means it will need another resource, that is your keyboard. Okay. So at that moment, it is waiting for me to write something from the keyboard. So sometimes it is running, sometimes it is ready to run, sometimes it is waiting for some resource. Okay. And at the end of 1 hour lecture, this process will complete and I will close this window. That means I will terminate it. So considering this situation or the state what is it currently doing, a process has 5 states. Okay, new, ready, running, waiting, and terminate. Okay, so when a process is created, for example, from the list of the application that I have, I created this process Paint 3D. Okay, so that means a new process, this one, a new process was created and admitted to the ready state. So when we talk about ready state, वो कहाँ पे है? Computer में ready state कहाँ पे है? So when from the secondary here, when from the secondary storage, I bring that program and put it in the main memory. When from the secondary storage, I bring that program, it is created and I submit it to the main memory. That is when it is called as in ready state. So in the main memory, it is given certain resources. Now you can access certain resources. Then it is called to be in ready state. Okay. So now यहाँ से जब हम इसको select करके खोलते हैं, a process is created and it is submitted to the ready state. And in the ready state, it will be put in a queue. It may happen so that in your main memory, there are many things. For example, I am using browser here right now. The browser is using Google Meet. Okay. So to you, it may seem ma'am is using only 2 applications. No. In the background, it is using more applications. For example, it is using my audio. मेरा computer में जो audio microchip है, वो use कर रहा है वो. And it is also using one more application of Google Meet, which is taking all this stuff, this whatever I have written here in my Paint 3D, it is taking this image, carrying it, processing it, carrying it, and sending it to your end. Okay, so there are so many programs that is running in the background. Okay, so what happens is when I am shutting my mouth down, so that means currently the audio chip, the speaker of the computer is on hold. Right now, if you will see, I am not using my mouse, neither am I using the keyboard. That means these are the 2 resources that is being on hold. However, the speaker of the computer is in use. Okay, so depending upon what resources it is using, it will end up in waiting state and in running state. Okay, so when a new process is created, we call it as a new state, and when it is submitted to the main memory, it is called as your ready state. And I told you in yesterday's lecture only, at a given point of time, let us say at t equals to, let me write down this time only, the timing of the computer. In the computer, the current time is 10:12. Okay, so right now it is 10:12 in my computer. Okay, so at 10:12, my computer, in the main memory, what all do I have? Kernel of operating system, it is there. Operating system to काम कर रहा है. Apart from that, I have my Paint 3D. I have my Paint 3D here. I've also opened Google Chrome. So I have a Chrome browser open, and at the background, which is not visible to you and me, but at the background, my speaker is working. Okay, and there are so many. Let me write down one more application is currently in use. That is my network. There are so many applications currently working. So in memory at a given point of time, we can have many processes. We can have many processes in the ready state in one go. And that many processes that is there in the main memory, we call queue. There is a queue process in the ready. But right now, because I'm using only the Paint 3D, so only the Paint 3D is there in the CPU. The moment I'll shift from this Paint 3D to Chrome, the Paint 3D will come out of the processor, and the Chrome will be sent to the processor. Okay, so that means जब कुछ चाहिए, if there is something that is needed by the processor, it will enter into the running, and if there is some interrupt, it will go to the ready, and if it has some resource to wait for, it will enter into the waiting state here. It will enter into the waiting state here, and then remember, the process is waiting for some resource. Let us say if this process is कौन सा process बोल सकते हैं? Okay, printer. Okay, so it is what that you're currently running in the process, running, and now you are giving control P, but that printer is being used by somebody else. So what happens is, from the running state, it will enter into the waiting. It will wait for printer to be free. So once the printer is free, remember, it does not goes to the running. Once the printer is free, it has to enter into the ready state, update its current values. Okay, now I am come from waiting to the ready, then ready will send it to the running state. Okay, the reason why we do this, why we send from waiting to the ready, is if we do not do this, then the system will enter into a very complex situation. There will be too many processes waiting for something. Directly there are 5 processes waiting for printer. Now there is one printer, let us say there is only one printer that is now freed. Now all 5 of them will consider that printer is being freed. Okay, so all of them will try to catch it and enter into running state. Lekin 5 processes cannot enter into running. Only one process at a time can enter into running. So now, because all 5 of them wants to enter into running, there will be a deadlock situation. Yeah.
मैम आवाज ब्रेक हो रहा है मैम.
Okay, so I will try to go slow. Okay, so now what happens is, once a processor is created and it is brought into ready, okay, so after it gets the resource, let us say a process can enter into running if it gets keyboard. So now it has got the keyboard, now it will enter into the running. Running means now it is there in the CPU. Okay, जब तक ready है तब तक main memory में है, जब running है ये है हमारा processor, central processing है. Okay, so now when it is in the CPU, that means when it is in the running state, to that process, 2 things happen. One, interrupt may occur. Interrupt is something that is not done by us. That has occurred because of some issues that has happened voluntarily. हमने उसको नहीं किया है, वो पता नहीं कैसे और क्यों हो गया, that is your interrupt. So sometimes right now, like I was talking and you said, ma'am, your voice is breaking. So that was not desirable. Okay, so that is an interrupt. That was undesirable, but because of network issue, there was an interrupt. So at your end, at your मेरे end में तो मैं continuously running थी, but at your end, your processor for that short span of time was going from running to the ready state. वो होता है interrupt, जो desirable नहीं होता है लेकिन हो जाता है, and because of that our process comes out of the CPU and enters into the main memory, running से फिर से ready में. Okay, but when a process is in the processor or the running state, apart from interrupt, it may enter into another state if it willingly needs some resource that it currently does not have. Let us say you were doing word में आप आपका assignment लिख रहे थे, it was there in the run state. Now you want to print it. You have completed your assignment. Now you want to print it, but the printer is occupied by some other process. Okay, let us say notepad print कर रहा है. Then your printer is occupied. So in that case, you will enter from running to the waiting state. उसमें यहाँ पे एक memory use होता है. वो memory वाला part हम बाद में. When it is in the waiting, it is not in the main memory. It is using some sort of memory. You already know about buffer, cache and all. So मैं अभी नहीं बताऊंगी, आप कंफ्यूज हो जाओगे. तो ये अभी ना मेन मेमोरी में है ना ये सीपीयू में है. इट इज देयर इन दी अनदर टाइप ऑफ मेमोरी, वहां पे चला जाता है and it waits for the printer to be free. So see here, running, waiting, we have input output event. Some input output event has occurred: printer, scanner, Xerox machine, keyboard, mouse, etc., etc. It needs something like that, and which is not free, so it enters into the waiting. So now let us say that printer is now free. Okay, that means that input or output event has completed. जिसने printer लेके रखा था, it has completed its task. The printer is now free, and now it again enters into the ready state. That means it has been uploaded from that type of memory. वो primary memory ही है. Okay, वो secondary memory नहीं है, primary memory है, लेकिन other type of primary memory है. So it enters from that primary memory into the main primary memory, that is your RAM. Okay, and then from here it will grab that printer, enter into the running state. Okay, so to go from ready to the running, that is to go from main memory to the processor, CPU. See here, to go from ready to the running, that means memory is one type of resource, CPU is another type of resource. Okay, so to go from here, it cannot go on its own. For example, if wherever you are, let us take an example, you are at one airport, like let us say Guwahati airport, and you want to come to airport at Sikkim Pakyong airport. Okay, so now you are ready to fly from Guwahati to Pakyong airport. Will you be able to come just because you are ready? No, you need one aircraft which will lift you from there, Guwahati to Pakyong. So you need one aircraft, right? Similarly, you are there in the main memory, you have got all your resources. Now you want to go to the processor, central processing unit. You are ready, but you cannot go on your own. So to go, just like you need a flight to lift you, similarly to go from here to here, we need a dispatcher, and we call the dispatcher as scheduler dispatcher, which will carry you from, which will, or हम अगर OS की भाषा में बोले तो which will perform context switching from main memory to the CPU, जिसको एक scheduler dispatcher होता है. It will dispatch you from main memory to the processor. So it again goes from ready to the running. Always ready to running. If interrupt occurs, then running to ready. But if it's not an interrupt, if it was desirable, you wanted that to happen and you're waiting for something, then you cannot see here. From waiting to running, there is no error. So if by your wish you have entered into waiting state, back to ready, you will have to update your process control block. Okay, I want this resource, so it will update its value, and then it will go back to the running state. Once you have completed everything, then that process will go to the, can be closed or terminated. Okay, we call it as exit. That is when in this paint with 3, if I'll click this portion, that means I'm terminating this window or I'm terminating this process. Okay, so this is the closure. So this is how new secondary storage, ready main memory. It is currently running CPU. Okay, so it has to wait for something. So other form of primary memory, buffer cache and all, it goes to the main memory again. Okay, and then goes to the running CPU, and if it is done, it is terminated. And if you do not need any waiting and no interrupt has occurred, from ready you will go to running. You don't need any resources. Okay, so you just use the CPU to complete your task and you close that process. Okay, so this is your process. These are your process states, 5 process states. These are the various resources. When we, जब ready में है तो कहाँ पे होते हैं, running में है तो कहाँ पे होते हैं, जब resources चाहिए, how do we move, how does the change of state happens, how does the transition happens. Okay, so this is all. So is it clear? Any question from this one? Can I move to the next topic? Any questions from this topic? Students, any questions from this topic?
No, ma'am.
Girls?
No, ma'am.
Okay. Okay, so I'll take 10 minutes more. Okay, I had 4 topics to teach, but this topic itself took a lot of time. So I'm going to teach only one more topic. Okay, so the second topic that we are going to discuss today is your process control block. Okay, process control block. Okay, so as I told you that when we talk about processes, there are different states that are associated with process control block. Okay, it is there in the secondary memory. From the secondary memory, it is brought into the main memory. From the main memory, it is sent to the central processing unit. And if we need certain resources from the central processing unit, it is sent to the cache. Other form of primary memory. Actually, it is cache. Okay, it is brought to the cache. When it gets its resources from the cache, it again goes to the main memory. From the main memory, again goes to the CPU. From the CPU, if the job is done, the process is terminated. Okay, when there is lot of shifting happening between secondary memory, primary memory. Primary memory, we have main memory, we have buffer, we have cache, and there is shifting happening between these types of memory only, and also from here to the processor, central processing unit. There is so many shifting happening. Okay, so this shifting will lose the value. Okay, process ka what was the last value, how far had the process reached, how much of the task had it completed before it shifted from one resource to the another resource. The value of the process has to be saved, so that when we go back to that process, the last updated value is still there. Okay, uske liye we use a stack. Okay, if you have to do the programming, then you will have to use a stack. Okay, so that stack is called as process control block. Now I will tell you to go with the name. Okay, to go with the name. मैं हमेशा students को बोलती हूँ, if you want to remember what the definition, always try to understand the title or the subtitle. Okay, process, we have already studied a programming and execution. So what is PCB? It is a control block. That means I have a block here. Okay, I have a block here. So this block is there to control the process. So that means this is a block. What do I have in this block? Inside this block, I have a process. Let us say a calculator that has been opened. Okay, a calculator that is open. Now I want to control this calculator. Let us say this is my calculator. 1 2 3 1 2 3. This is my calculator. I have opened it. Now this is a process. Okay, so from this calculator, and this is my paint 3D window that I'm using right now. So I'm continuously shifting from calculator to paint 3D to calculator. I'm continuously shifting like this. So when I'm shifting from here to paint 3D, its value should be saved. Okay, so that means I'm trying to control it. So when I try to control, if I have a block that controls the process, we call it as process control block. And programmatically, ये कंप्यूटर का अंदर ये क्या है? ये एक stack है. Okay, every time a process is created, an associated stack is being called by the operating system to store the values of the process that is being currently used. If I have 5 processes submitted to the main memory, 5 PCB. If 10 processes submitted to the main memory, 10 PCB. To each process, a PCB is associated. Okay, so what we are going to study next is what are the various components of this PCB. Okay, so as I already mentioned to you, it is a stack. Okay, so at the top of the stack, I have something. So this is the content of your stack. Okay. Okay, so right now, this is your process control block and its associated fields. Okay, this is your process control block and your associated fields. So what do I have in my PCB at the first? Okay, at the first, I stored the process state. At first, I will store the state. Okay, process state. So whatever is the process that I have right now, what is the state of that process? For example, the browser here. Okay, to talk to you, I've opened browser. So the browser is my at the back right now. I am currently using this resource, display screen and keyboard and mouse. Okay, so this is in running state. Okay, this browser is at the back. This application or a process is at my back end. Okay, so that what is the state of that browser? What is the state of this current application, that is your paint 3D that I'm using? Okay, so ये ready state में है या फिर running है, whether it is there in the interrupt state, waiting state, ready state, running state, new state, terminated. What is its state? Okay, that state has to be associated for any process. Let us say for P0, this is paint 3D. So paint 3D, what is the current state? Running. So here the value to the in the main memory for this PCB running will be written. Okay, so that means this process is currently in running state. Sorry. Okay, so the next is your process number. Okay, process number. Process number. Now, if I have opened 10 processes, the computer does not remember these 10 processes by name. Like it will not remember it as paint 3D, browser, calculator, what else? Python, sorry, Anaconda, etc. etc. It will not remember it like that. Okay. To each process, it will assign one number. Let us say paint 3D 0. So it will be called as P0 process. Calculator P1, browser P3. So to each process, a number is associated, and that we call it as process number. So to this running here, I have running for Paint 3D, and if Paint 3D is given the name as P0, here it will write P0. So that means P0 is currently in running state, like that. Okay. So next up I have, let me write down now each one, then I'll explain each one. Okay. The third is my program counter. Let me write down first so that I can use my brush to explain each one. Program counter. And then next up I have registers. These are important. Registers. Registers. There will be many register. And then next up I have memory limits. It is important. I have memory limits. Next up I have list of open files. What all files a particular process has opened for it to complete the task, okay? And any other information if there is. For that we have one extra block. Okay, students. So these are the various fields. Let me write down that as well. This figure is your process control block and its associated fields. Fields के spelling क्या है? If I'm wrong में fields के spelling में हमेशा confuse हो जाती हूँ. So if I've written the spelling of field wrong, please pardon me and write it in the correct way. Okay? So I always get confused with this spelling. Okay. So let me use brush now. So I've already told you that let us say this is my Paint 3D. Okay, so Paint 3D I'm using right now. Let me take this example only so it will be easier for you to understand. So now what is this Paint 3D right now? Right now it is in running state. Okay, so now I have already told you. Now the moment I had opened it, a PCB was, one stack was created by the operating system. Okay. So on that stack, it will have these many fields, okay? And if there are other, depending upon the operating system, the version, it has provided many more fields, okay? Version ke according, whether if it is Mac, if it is Windows, if it is Linux, their names are different, okay? Their fields are different, okay? So these are the common ones that you'll find everywhere, okay? And if it's Linux, you want to update your own, okay? So that option is also there. So let me say that this is my Paint 3D. So Paint 3D is in running state. Okay. So in the process state, what will I have? It will have either new, ready, running, waiting, halted, and so on. So for this Paint 3D in here, in this in the topmost layer of your stack, you will have running. Okay. So next is process number. So now to this Paint 3D, it will not write here Paint 3D. It will write down, it will assign to this Paint 3D one process number. Let us say it assigns P0. So here that means P0 is here. Okay, so P0 is in running state right now. Next is my counter. Okay, so this counter is important. The counter is important because it stores address of the next instruction. Okay. For example, let us say your process is very big. You are executing a process which is very big, which cannot be fitted into the processor in one go, and you have divided in the big process into smaller parts, and you are executing it. Later on, we'll study something called as paging. जिसमें हम बड़ा process को छोटा-छोटा बना देते हैं. Okay. So now first process is done. So we need to know where is the second half of that process. Okay, for example, let me take one example, Word file. MS Word, you are writing assignment. Okay, so let us say it has 100 pages and you have given Control P. Okay, so it is printing that page. However, you know that while it is printing, you can edit that document. Okay, so that means you're simultaneously doing two things. But when you are pressing the control P at the back, whatever word file you were writing, that state has to be saved. And also for control P, after control P, where should you go? What is the address of that particular remaining portion? Okay, so that address to the next process, same process ka remaining portion ka, what is the address is stored in your program counter. Okay, so the counter indicates the address of the next instruction to be executed for that same process. Same process, what is the next address? It shows that. And always remember that every time we exit or re-enter into that same process, that address has to be updated, because after let us say at t equals to 0, out of 100 lines of code you have executed, at t equals to 0, 10 lines. So your this counter value has to be 11, because your next line of code is your 11. Okay, so now in the second go, it goes from 11 to 15. So for the next process, same process, next for second block, it will enter 16, because the next address space is from this 16. And now this address space, we are talking about address space, and what address space are we talking about? This address space is the address space of your main memory. Okay, so let us say this is my main memory and I have here kernel, operating system kernel. So let us say this is the main memory of 512 MB. I have 512 MB here. So let us say this is my page. Okay, so this is my process P0 in the main memory. Okay, and it has, let's say, the system has occupied from 0 to 9 bits, and it has a main memory, and it is occupied from 10 to 200. Okay, 10 to 200. So right now, if I'm executing this many portion, that means I am, let us say, in 100. Okay, so it is basically storing, this program counter is basically storing these addresses. Okay, main memory instruction. Right now I'm writing this one. So let us say for 2D shapes, it calls a different subprocess inside here. Okay, different subprocess. So that 2D shape is the next instruction code. Let us say in the Paint 3D, I was here drawing. With this I was drawing. I click here 2D shapes, which falls in this 101. So this is the next chunk of this code. Okay, so it stores 101 as the next address space. Okay, so next is your register. Registers, you already know, it is basically a collection of flip-flops. If we are to talk about with respect to hardwares. Okay, so now it is like stack pointers, index registers, accumulators, etc. So that these numbers, these values are stored in the hardware. Okay, so the registers vary in number and type. How many registers are there, how many type are there? Depending upon that, the cost of the computer also increases. If the operating system is given more number of registers, that means it can, in one go, it can store lots of information. Okay, so you are increasing the space. So, increasing the number of registers, the cost also increases, and it also can remember lots of information. Okay, it will accumulate lots of registers and all to remember all this information. Okay, so the purpose is to remember. They include accumulator, index registers like this one. What is its index? Okay, so stack pointers to point to the next process states and all. Okay, it will have other general form of registers. Okay, so but each register will have a number and a type. Okay, what type of register it is, what is the purpose of its register, all that depending upon the need we have to select the registers. Okay, so next is memory limits. We know that for each process a memory limit is there. For example, it starts from 10. Okay, it starts from 10, it is ending in the 200. So its memory limit is 10 to 200. It has to remember it. So now next is the list of open files. Okay, sometimes what happens is if let us say let us say you are preparing for PowerPoint. In that PowerPoint, you are connecting that PowerPoint to the database. You are hyperlink a page. You have that particular PowerPoint. That means when you are opening one process, other files are associated with that process. Okay, so what are all the files? When I open that process, when I open PowerPoint, that means all these files should be ready in the background. Okay, so what are the list of all these files that is associated with one particular process, and what all file does it need? All that has to be included in the PCB of that particular process. Okay, that means when we open a process, it's not easy. Okay, every information related to that process has to be made ready, and it has to be included in the PCB, so that when we are in the need of that particular process, we do not move from this location to that location. Storing all the related information in one particular stack will smoothen the process, will save the time taken by the process to shift or to open itself. Okay, the moment I opened the Paint 3D, it opened all the smaller programs. So now the smaller program has been converted into processes. So I go to the menu. If I'll click here menu, I want to open something. So the moment I'll click here the open, all the associated files that is there in the computer that can be opened from the Paint 3D is being made ready. Okay, so all the associated files, what are the list of the files, will be, you can store it here. Okay, but this field is optional. All these things are not, sorry, list of open files field is not there. You will not find it in every operating system. Okay, in Windows you will find it. Linux, I think it is there. Okay, but other than this two, it's not compulsory, it has to be there. Okay, so apart from that, I have here done here dot. Okay, so what are the other information that PCB can possibly have? It can have the scheduling information. It can have the, we know that we have two types of very important memories, that is your main memory and the processor, CPU. Okay, so if we want to perform multi-programming, then we have to manipulate, we have to overload the use of main memory and CPU. Okay, so we have to perform scheduling. What is scheduling? I'll teach you in the next lecture. Okay, so process control block can also store the information of CPU scheduling, memory scheduling. Okay, apart from this, there is one block which is very important, and we call it as input output information. Okay, so it will have one more block here which will include this input output information. That means associated with a particular process, what all input output resources does it need? For example, this Paint 3D needs my keyboard to write something. It needs my mouse so that I can hover around this page. Okay, but what it does not need is, right now it doesn't need a printer. Okay, so the moment I open this Paint 3D, this Paint 3D process must make sure whether I have this keyboard and mouse or not. If it can read it through the drivers, if the driver is not installed, even if I will have this, they will not be able to use it. So what are the resources, input output resources, that a particular process needs to complete a task, also has to be listed and stored in the PCB, so that the operating system will know that, okay, so this process is currently in execution and it has occupied these many resources associated with this computer, so that when another process will ask for that same resource, the operating system should be able to tell that another process P1, no, I cannot give you this because this has already been occupied by P0 and is in use, it is not free. And that second process will enter into the waiting state. It will wait for P0 to free the keyboard and the mouse. Okay, so this is all about your process states and your process control block. Any questions from today's topic? If yes, you may fire the questions, queries. If not, this is the end of the class. Wait for some time. I need to update your attendance. Okay. Any questions, students? Class, any queries? Class, any queries?
No, ma'am.
Okay, the attendance has been stored. Okay, so if you want and no queries you have, you may leave the classroom.